In this video we're just going to work through the reasoning and communication question from 1.06 on page 32. Question 7. A theme park charges $78 for adults and $48 for children. A party of 21 people paid $1,188 altogether. How many adults and how many children were there? So the first step is to identify the important information. So we have $78 for adults, $48 for children. There was a party of 21 people and total amount was $1,188. Okay, and we're asked, next thing, identify what we're actually asked. So we're asked how many adults and how many children were there. Now, what you want to do from most worded problems, well, especially simultaneous equation worded problems, we need two equations. So we're being asked for two variables, how many adults were there, how many children were there. So we need two equations to find the solutions or the answers to the two variables. So if we study this for a bit, it might take you a little bit of time to work out the equations. I had to pause the video for a second to work them out. But let's have a look at what we can get. So we know that each adult is costs $78. So let's define some variables. A equals the number of adults. And let's say C equals the number of children. Okay, now we can start writing some equations. So $78 for adults. So 78A means the money that you get from adults, you get the number of adults that you had and multiply it by $78, and that will give you the total amount of money you get from adults. Now if we add the $48 for each child and multiply it by the number of children, we have 78A plus 48C. We will actually have the total amount, $1,188. 1188. So we know the number of adults, A, multiplied by $78 each, plus the number of children, C, multiplied by $48 each, gives us the total amount paid of $1,188. So we've actually used 1, 2, 3 pieces of information. Now, we've still got a missing piece of information we haven't used, this party of 21 people. And we'll use that in our next equation. So there were 21 people altogether. So something equals 21 people. Now, what was the total of, where did that come from? Well, it's a party of 21 people. It's the number of adults plus the number of children. So, because they're either adults or children, so A plus C equals 21 people altogether. So now we have two equations, equation 1 and equation 2. And that is really the hardest step in any mathematical problem, is turning your words into equations, or turning your words into a starting point. Now from here we can actually start solving. So I'm going to use the substitution method because that's what I prefer. So we can start with equation 2. We can just say A equals 21 minus C, just moving the C to the right hand side. And then we can say sub 1 into 2. And so now we're going to replace, where's equation 1? Up here. We're going to replace this A in equation 1 with this 21 minus C, because we know A equals 21 minus C. So not sub 1 into 2. This is going to be equation 3. And we're going to sub equation 3 into equation 2. Sorry about that. Okay. Sorry. Screwed up again. Sub equation 3 into equation 1. Okay, so as I've circled up here in the green, we're going to use equation 1. We got that A equals 21 minus C. We're going to sub that into equation 1. We can't really sub that back into equation 2 because if you sub that into equation 2 and collect your like terms, you'll just end up with 0 equals 0, so it doesn't really give us anything. So we have to sub that into equation 1. So sub 3 into 1. So 78, therefore 78 times A, which is 21 minus C, plus 48C equals 1188. Cool. So 78 times 21 equals 1638. So therefore 1638 minus 78 lots of C plus 48 lots of C equals 1188. Negative 78 plus 48, I think that's, what, negative 30? Yep, the 8's go, 7 minus 4 is 30, cool. Therefore 1638 minus 30, I forgot my C in there, from the expansion, minus 30 lots of C equals 1188, and then we subtract 1638 from both sides, so 1188 minus 1638 equals, so we have, therefore, negative 30C equals negative 450. We got negative on both sides, so you can always multiply everything by negative 1, and you would get 30C equals 450. So when you got negative everything on both sides, you're essentially multiplying everything by negative 1 to switch your signs to positive. Or you can just rewrite it positive. And then finally we divide by 30, so 450 divided by 30 gives us 15. So we know that C equals 15. Therefore, there were 15 children. Sorry, that was very messy. There were 15 children. Cool. We'll go back to the beginning. We know there were 15 children. We can actually start from this point now. We have here A equals 21 minus C, so there were 21 total. Now we can sub C equals 15 into equation 3. So this was equation 3, A equals 21 minus C. A equals 21 minus 15. Therefore, 21 minus 15 is 6. So A equals 6. Okay, we have two things. A equals 6, C equals 15. Now, the important thing with any worded problem is finish it off properly. Make sure you answer it in words. The question was given to you in words, so answer it in words. So we say, check the question again, how many adults and how many children were there? Okay, we can write, there were 6 adults and 15 children. And that's it. That's your final answer.